I showed you some examples how to multiply points that are from our polar plane or complex numbers written in polar form. We can also find their quotients as well. When we take 2 points in the complex plane that are expressed in polar coordinates or in polar form, we can take their quotients. And I went ahead and put this formula there on the board. We could derive it very similar to how we derived the last one. And so I have 2 points that we wanted to show you how we would do that. So I have point 1, point 2. Follow this model that we were able to derive or could derive. This says is first take the ratio of the moduluses. So 12 divided by 4. Then I have the cosine, and always put a soft bracket on it. I should put a hard bracket because there's another one coming on up. So the cosine of the first argument, which is 3/4 pi, minus the second argument, which is 1/4 pi, plus I times sine of the argument, which is 3/4 pi, minus 1/4 pi. A couple things I want you to note. When we're taking quotients, you notice 2 things. One, the ratio. We take the ratio now, or the quotient of the moduluses, and then I'm subtracting, or I'm taking the difference of the argument. That's different than when we're multiplying 2 points. And then I reduce that down. 12 divided by 4 is 3 times the cosine. 3/4 pi minus 1/4 pi gives me 2/4 pi, or 1/2 pi. And there we go. I was able to find the quotient of 2 points in the complex plane that are written in polar form, and I was able to take the quotient of that.